example 4 for 2.2 in Math 20-1, and we're going to deal with a quadrantal angle. And quadrantal angles are where the terminal arm lays on one of the axes. So that's 0 degrees, 90 degrees, 270 degrees. Did I forget? Sorry, 0, 90, 180, 270, and 360. And then they repeat what you learn later in Math 30. Basically, the problem with the quadrantals is that they're not in any quadrants. The quadrantal angles separate the quadrants from each other. So we're not going to be able to use, we're not going to be able to use the same technique we used before, but I really do want to push that sine theta, cos theta, and tan theta are still equal to the same thing. So sine theta is equal to y over r, cos theta is equal to x over r, and tan theta is equal to y over x. What we need to determine is what does that look like when it's at 90 degrees? So I'm going to draw that. 90-degree rotation would take us from 0, and then my terminal arm would point straight up. Now, what a lot of students struggle with is we could actually pick any point on this terminal arm. So somewhere along here, I'm going to pick a few, would be, 0, I'll put it 1,000, so my scale's crazy. We could have, 0, 500, and there'd be a bunch of points we could use. Technically, there's infinite points. Now, if you get to choose a point, you should make it a nice number. And I think the easiest way of doing this question, I'm going to draw another diagram for it, is I am going to pick kind of the simplest number that's not 0 that I can think of, which is positive 1. So we're going to talk about this terminal arm rotating and eventually getting to the point at 0, 1. Now, in order for that terminal arm to hit 0, 1, what's the radius of the terminal arm? And the reason I talk about the radius is typically students don't have a trouble with x and y because I wrote the ordered pair, right? So I'm going to put 90 degrees there. At 90 degrees, x is equal to 0, y is equal to 1. What's r equal to? And this is a really important thing to be able to do. And, a lot of times in chapter 2, I'm going to talk about kind of a memorization technique, and then I'm going to talk about a logical technique. And I really do think the memorization techniques are going to work. They're reliable. They're usually algebraic. The logical techniques typically develop deeper understanding, and so they're worth doing. But in this question, I am going to show the kind of algebraic technique everywhere. When we draw an angle in standard position, r squared is equal to x squared plus y squared. Well, I know x and y. So r squared is equal to 0 squared plus 1 squared. That means that r squared is equal to 1. That means that r is equal to, and I'm going to put positive negative 1 there. But remember, r is defined as a distance. It is always positive. So we would say that r is equal to 1. Now, the logical concept is because this point is on the end of the terminal arm, 0, 1 is 1 away from the origin. So there's two different ways of getting that r is equal to 1. All right, the rest of the question wants us to determine the value of sine theta, cos theta, and tan theta. And I'm going to do that one after the other, identifying that the values of x, y, and r really allow us to do this. So the sine of 90 degrees, because we know the angle for this question, is y over r. Y is 1, and r is 1. So the sine of 90 degrees is 1. 1 divided by 1 is still just 1. The cos of 90 degrees is going to be x over r. Well, x is 0, while r is 1. So the sine of 90 degrees, I'm going to put the simplified versions over here. The sine of 90 is 1. The cos of 90 is 0. And then we get the oddball. And tan is often like this because it's the ratio of y and x. When I try to do this with 90 degrees, the y is 1 and the x is 0. Well, what's 1 divided by 0? And the reality is that it doesn't exist. And what we call this, or what we label this as, is undefined. And I like explaining where that comes from. Keeping in mind, the context of SOHCAHTOA, if I were to draw a triangle, and if we looked at the opposite over the adjacent, then what's going to happen is as this triangle has a larger and larger angle, that ratio gets bigger and bigger and bigger. But what happens when you draw a triangle with 290 degrees? The problem is now this side is parallel to this side, and so they never meet. So if we try to draw a triangle that contains two 90-degree angles, we don't have a triangle anymore. We have a weird kind of parallel line with a connection at the bottom. That's why the tan of 90 degrees is undefined. Algebraically, and really, it's fine if you understand it as what I did on the board here. The hardest part for students is recognizing that if we look at a quadrantal angle, you get to pick a valid x and y. And I really would like to show just really, really quickly that let's say I didn't go with 0, 1. Let's say I went with 0, 10. If I picked 0, 10, X is still 0, Y is 10, sure, but now R is 10. Well, 10 divided by 10 is still 1, 0 divided by 10 is still 0, and 10 divided by 0 is still undefined. So the reality is that any point on that terminal arm will work with this technique. I just like to choose 0, 1 because it's easy to work with.